Good morning, dear students. In today's video lecture, we will discuss about the continuity of a function. Dear students, in mathematics, a continuous function is a function for which intuitively small changes in input results small changes in output. Then function is called continuous. Otherwise, function will be discontinuous. So, a continuous function this term implies that small changes in input results small changes in output. Small changes in input results small changes in output. And a continuous function is a function whose graph can be drawn without lifting the pen from the paper. So if we draw the graph of function, and to draw the graph of function, if we can draw the graph without lifting the pen from the paper, then function will be continuous. For example, let us take ht is a function which describes the height of a boy at time t. Then this function will be continuous. In fact, in nature, everything is continuous. So if we consider ht is a function which describes the height of a boy at time t, then this function will be continuous. In fact, in nature everything is continuous. So there will not be a sudden jump in height of a boy in certain very small time interval. Therefore, this function is continuous function. Consider another example. Let us take another example. Let mt is a function which describes the amount of money in a bank account. Then the function jumps whenever money is deposited or withdrawn. So this function is discontinuous. So dear students, let us see what we have discussed so far. A continuous function, this implies that small changes in input intuitively, small changes in input results small changes in outputs. A continuous function is a function whose graph can be drawn without lifting the pen from the paper. For example, let us take ht is a function which describes the height of a boy at time t. Then this function will be continuous, because in very small time interval height of boy cannot jump abruptly. In fact, in nature everything is continuous. Let us take another example. Let mt is a function which describes the amount of money in bank account. Then the function jumps whenever money is deposited or withdrawn. So this function is discontinuous. Now we come to the definition of continuity of a function. Let us define the continuous function. Definition of continuous function or continuity of a function. So when we say a function is continuous, a function fx is said to be continuous at x equal to a if limit of function fx when x tends to a minus is equal to limit of function x tends to a plus is equal to f a. That is, this implies that left hand limit is equal to right hand limit is equal to value of function at x equal to a. So this means if a function is continuous at if a function is continuous at x equal to a, this means limit of fx when x tends to a minus is equal to limit of fx when x tends to a plus is equal to fa. This is the definition of continuity of a function. This expression written in the box represents the definition of continuity. So if limit of function fx when x tends to a minus is equal to limit of function when x tends to a plus is equal to value of function at that point x equal to a, then function is said to be continuous at x equal to a. This expression is left hand limit of function. This expression is the right hand limit of function. So left hand limit is equal to right hand limit is equal to value of function at point x equal to a, then function is called continuous function. When function is said to be discontinuous. So in short we can write limit of fx x tends to a is equal to fa. Here limit of fx x tends to a. So this limit exists when function's left hand limit and right hand limit both are equal. So in short we can represent the definition of continuity by this expression also. Now we talk about the discontinuity of a function. So discontinuity of a function. A function is said to be discontinuous at x equal to a if number 1, if limit of fx x tends to a minus is not equal to limit of fx x tends to a plus. That is if limit of function does not exist at x equal to a. Second, if limit of fx when x tends to a is not equal to fa. That means limit of function exists, that is left hand limit and right hand limit of function at x equal to a are equal, but limit are not equal to value of function at x equal to a, then function is discontinuous.